All right. Yesterday, we looked at an introduction to limits by taking a numerical approach. So we looked at tables and we kind of saw numerically, looking at the function values, what was happening there. Now, one thing that we saw is that even when the function value did not equal the limit, so one of the last examples that we looked at was this one here, where we saw that as we approached 1 from the left, we got 3. As we approached 1 from the right, we got 3. But when you plugged in f of 1, we got an undefined value because there's a hole in the graph. If you think about what that would look like, that would mean we have something that's going towards 3, something that's going towards 3, and then we have this empty hole, and somewhere else maybe that value might get filled in depending on the function, but we don't know. But even though that value on the graph doesn't exist, the limit here was still 3 because as I approached from this side, we approached 3, and as I approached from this side, we approached 3. So that is one of the things that has to happen in order for a limit to exist, is that from both sides, that means looking from the left and looking from the right, that we have the same value that we are approaching. And once again, the whole point of a limit is that we're going to approach a certain value, but we don't actually have to get there. That is one of the hardest things, I think, to kind of get in your mind. You don't have to have a point that you're going to get to. You just have to be heading towards the same area, okay? So now what I want you to think about when we look at these limits is I want you to think of it kind of like a GPS, okay? So if I'm standing on the right of the graph and you're standing on the left of the graph and we both start walking towards the same place on the x's, are we going to get to the same spot? Are we going to be approaching the same location or not? So for example, let's look at this g of x graph. And let's think about the limit as x approaches 2 of g of x, okay? So I'm going to go from the right-hand side, which means I'm going to start over here. This is me with my hair. I'm going to start over here, and I'm going to start walking towards 2. You're going to start on the left-hand side, which means here's you, and you're going to start walking this way towards 2. Think about what is going to happen in this case. On my side, I'm going to start walking this way, and I'm going to follow, and when I get to 2, the y value that I'm approaching would be 0. Hopefully you can see that. Now, if you start walking from the left-hand side and you follow the graph, and you also, even though you take a little bit different route, eventually you end up approaching 0 as well. We both are looking at this. And remember, our g of x value, that's the y value. So as x approaches 2, g of x is approaching 0. And so that would be the value of our limit here. Okay, so I'm going to kind of zoom out so you can see all the pages, and we're going to talk through some of these examples on this worksheet here. Okay, let's see how far I can zoom in. That's probably it. Okay, so make sure you pay attention to whether we're talking about f of x or g of x. And we're going to kind of look at this and we're going to practice and learn some notation. Now, one thing that you will notice is if you look at, for example, number 2, or you look at, for example, number 5, sometimes we have these little plus or minus. They're almost in the exponent position. Just as I was describing to you looking at the limit from the left or from the right, that's what that little plus or minus means. So if I were to say the limit as x approaches a with a little plus like that of, let's say h of x, since we already have f and g. This means, this plus right here, means to approach a from the right. okay? So that would mean start on the positive side of the graph and walk towards whatever value. From the right would be starting over here and moving across the graph this way, okay? If it has a little minus, so let's say the limit as x approaches a with a minus up here of h of x, that would mean from the left. So again, that means start on the left-hand side of the graph and move towards your x value from that side. Now we can do both of those things, like on the example I showed you. If it does not have the plus or the minus, that means you have to consider from both sides. Okay, so let's work through a few of these. If we look at number 1, we want the limit as x approaches -1 of f of x. So we're going to go to the first graph, and here is -1. That's what we want to be approaching. So hop on the graph somewhere, and you can start all the way over from the side here. If we go from the left, we have to hop on this little guy and move this way, and then it jumps up to here, and we move this way until we get to a y value of 2. So right here, the limit is 2 coming from the left. Are we also going to get 2 if we come from the right? So you start walking over here, and you walk towards -1, and we don't get there. We only get to 1 right there. So what we say is that in that case, because the left and the right side don't agree, when we're talking about the limits, we say here that the limit does not exist, and you can always abbreviate that as DNE. And again, you might want to make a note to yourself that the left and right limits don't match. Okay, so we can't have different left or right-handed limits. But let's go over here and look at the limit of f of x as x approaches +1 from the right. Let me erase some of the stuff on here because I'm getting a lot of things going on this graph. Oh, sorry, you're going to hear my dog bark. That's kind of what he does. All right, so if we want the limit as x approaches 1 from the right of f of x, 1 is what we are going towards, okay? So we're going to come from the right, which means we want to come this direction. So the closest little branch to 1 is going to be right here. So as I move this way, what are we approaching? We are approaching 0. Now don't get thrown off by the fact that the function value is defined up there at the top. That doesn't matter. All that matters is that from the right-hand side, we are approaching 0. From the left-hand side, we would be approaching 2, but only from the right-hand side are we worried about right now. And so from the right-hand side, we are approaching 0. Okay, I would love for you to pause for just a moment and try number 3 and 4 on your own. Notice these are both talking about g of x now. So take just a second to pause the video and try number 3 and 4 so you can do kind of a mental check to see if you think you have the right idea. Okay, here are the answers that you should get. So notice as we approach -1, this is what can be a little confusing, is there's a hole and it's defined up here. But that dot up at the top by itself really does not matter. All that matters is that from the left, I'm coming towards 1, and from the right, I am coming towards 1. So basically, we're approaching the hole. We're not approaching that point. And that is all you need to know, is that you're approaching 1. The dot doesn't matter. If I asked you what is g of -1, you would say 2, because that's where the dot is. That's where the function is defined. But the limit as we approach -1 is going to be 1. And that is just like that second example when we were looking at the tables yesterday. And then I think it's a little bit easier to see the other one. If we're going towards positive 1 from the left, we go towards this point. From the right, we go towards this point. And those are both going towards negative 1. Okay, we are going to look just a little bit at 5 and 6. And we're going to save 7 through 10 to talk about as kind of a warm-up when I get back. So number 5, if we want the limit as x approaches 1 from the right of f of x plus g of x, then we need to kind of think about what f of x plus g of x is going to be as we move closer and closer. So let's consider these separately. The limit as f of x approaches, the limit as x approaches negative 1 from the left, that's what we need to start with first for f. So on the f of x graph, from the left, we want to go towards negative 1. That's going to be this branch here. And we get a value of 2. And then we want to do the same with g of x. We want to approach negative 1 from the left. So that's going to be this red arrow that's already there, and that goes towards 1. So that means for our limit, we want to look at 2 plus 1, which is going to be 3. And that's the answer. So this is moving a little bit more into that abstract idea as opposed to just a straightforward limit. So try number 6 so that we can start talking about that when you see me next. And then feel free to go ahead and kind of think and make a guess on 7 through 10. That'll make it easier for us to talk about when I see you. But that is it for today. Your assignment for today is worksheet 1 and worksheet 2, which is over graphical limits in your packet. So you should be able to finish at least worksheet 1 during class and then take worksheet 2 to do at home. And if anything, you might be able to get them both done. So I will see y'all tomorrow.